Bristol Community College, Mathematics with Dan Avedikian, Math 131, Elements of College Mathematics, Section 5.3, Problem 2. This is Section 5.3, Problem 2, and it's related to the previous problem, Problem 1. It's interesting to compare the two once you get the answer to both of them. It says, Sandy's boyfriend John loves Sandy's new Toyota, so he bought one too. John also gets a 5-year vehicle loan for $28,000. But due to his bad credit history, John has to pay an interest rate of 18%. What are his monthly payments and how much interest does he pay? So if you remember the previous problem, it's also a 5-year vehicle loan for $28,000. It's all the same except the percentage. The other person paid 3%. So you can see 18%, what a difference it's going to make. It makes quite a difference. So anyway, let's figure it out for 18% and see what the payments are and what the interest over the life of the loan winds up being. So this is an amortized loan question. The amortized loan formula is P, the payment, equals A, the amount borrowed, over these really big, nasty looking brackets. The brackets have 1 minus 1 over 1 plus R over M to the M times T power in the numerator of the brackets, and in the denominator R over M. A big formula. So fill it in. P equals A, the amount borrowed for this question is also $28,000. Let's see, here it is, 28,000. And then underneath that you have those big brackets. In the numerator of the brackets, 1 minus, you have a fraction, in the top of the fraction a 1, in the bottom of the fraction 1 plus R over M. Now again, R is the rate as a decimal, so this one, the 18% as a decimal is 0.18 or 0.18. And the M that's underneath that is the number of payments made per year, and this is fairly standard at 12. And that's in some parentheses. It has an exponent. The exponent is M times T. The M, again, is number of payments per year, which is 12, times T, the number of years for the loan, is 5. This is a 5-year vehicle loan, pretty common. And in the denominator of the brackets, R over M. So again, 0.18 over 12. 0.18 is the R, the rate is a decimal, 12, M, the 12 is number of payments made per year. So that's how the formula fills in. As always, we're going to start our work in the parentheses. You have to do work in the parentheses first when you have parentheses in your problem. So what's going to happen, we'll have P equals 28,000 over some brackets. And in the numerator of the brackets, we'll have 1 minus some fraction. The fraction will have a 1 in the top. And in the parentheses, that R over M is 0.18 over 12. That's 0.015. And again, I can see things like this pretty easily without my calculator. Probably not everyone can. So you just do 0.18 divided by 12 equals, and the calculator will tell you it's 0.015. Now there's a plus 1 in front of that R over M, so you're going to have the 0.015 plus 1, which is 1.015. So that's in the parentheses. And I close the parentheses. It has an M times T power of 12 times 5. 12 times 5 is 60. And in the denominator, R over M is 0.18 over 12. And same division, same answer, 0.015. And as with a lot of these finance formulas, there's a same decimal in the denominator, and it's still a little higher up in the denominator, you could say. Same decimal, the higher up one has a 1 in front of the decimal. So at this point, what has to happen is the big exponent of 60th power. So I'm going to do 1.015 to the 60th power. And the next version of my formula is still going to have the 28,000 up on top. My brackets now will have, in the numerator of the brackets, 1 minus some fraction. But now the fraction is going to have a little simpler denominator. It's going to be a big decimal. It's going to come from 1.015 to the 60th power. So that I definitely need a calculator for. I put in the 1.015, hit the exponent button, enter the exponent of 60, and the answer I get is 2.4 0.4432197776. Again, that's a lot of decimals, but I'm just going to let them run until the end of the problem, and I'll round it off to 2 places when I finally get an actual monthly payment. And underneath, in the denominator of the brackets, I have a 0.015. So it's getting better. Now in the numerator of the brackets, I have 1 minus 1 over 2.4432197776. So let me do that 1 over 2.4432197776 and see what I get. So P equals 28,000 over some brackets. In the numerator of the brackets, I have 1 minus the result of that division, 1 divided by 2.44 something. And again, there's a variety of ways to do that. With a scientific calculator, there's going to be a button that says 1 over x. I just press that. That's the easiest way to do it, I think. However you do the division, the result will be 0.4092959966. And in the bottom of the bracket, you still have your 0.015. I'll close up my brackets. So now in the numerator of the brackets, I do have a subtraction that I need to perform, 1 minus 0.4092959966. So let me do that. When I do, I'm going to have P equals 28,000 on top still. And then the brackets will have 1 value in the numerator, 1 value in the denominator when I do the subtraction that I need to do. The numerator of the brackets will be 0.59070433, and the denominator of the bracket is 0.015 still. Now if I divide 0.59070433 divided by 0.015, I'll have 1 number in the brackets, which will be good. So when I do that, I have P equals 28,000 over some brackets with just 1 number in it. And that 1 number is 39.380268889. So all I have to do is divide 28,000 by 39.380268889, and I'll have my monthly payment. And like I say, it's easier probably to save the denominator of 39 point something in memory and then do 28,000 divided by memory recall. And the calculator says 711.015968. Now at this point, I'm at the end, so now I can round it off and get rid of a lot of those decimals. I only want 2 places after the decimal point. So I have 0.015 something. So the 5 is big enough to make it a 0.2. So the monthly payment will be $711.02. Now, if you remember, the payment from the previous problem was a little over $500. So it's a pretty big jump. It's more than a $200 difference every month. Now, over the life of the loan, how much interest are you paying back if you're paying $711.02 a month? Well, again, you're going to pay this every month for 5 years. So that's 60 payments altogether. You're going to make 60 payments of $711.02. So 60 times $711.02, we'll get an answer for that, which the calculator will do for me very easily. The total paid back to the lender will be $42,661. The calculator says 0.2, so it's and 20 cents. So the total paid back to the lender is over $42,000. Now again, $28,000 of that $42,000 something went to whoever sold the car. So I can subtract off the $28,000 that went for the purchase of the car. And I'll let the calculator do that for me. So the rest that went for interest is $14,661.20. And again, if you remember problem 1, the total paid for interest was a little under $2,200. It was like $2,187 something compared to $14,000. So that 18% versus 3% in problem 1 and problem 2, you can see the difference is almost enough for a nice used car in addition to the new Toyota that they bought. It's quite a difference.